Hello everybody, I'm Jay and I'm a member of the AI Skills Center at NewOrbit. Today I'm excited to talk about something that's quietly revolutionizing how we interact with large language models, Model Context Protocol, or MCP for short. If you're involved in software in any way or just trying to get a bigger picture behind how AI fits into the modern development, then MCP is something you should know about. The aim of this video is a high-level overview that will show why MCP is becoming such an essential tool for empowering developers to build smarter, more integrated systems, and for enabling AI solutions to operate with greater context, flexibility, and control. So what actually is MCP? I know Model Context Protocol sounds quite technical, but don't worry, even if you're not a super techy person, it's actually pretty straightforward. It's basically a way to organize and pass useful information to an AI model, kind of like giving it a quick rundown of what's going on before it has to actually do anything. And what makes MCP really powerful is that it doesn't just feed the AI information from one place, but it can bring in context from multiple systems across an organization, all in one structured request. This means you can make it easy to interact with your software from AI tools that your customers happen to use, including things like ChatGPT, Copilot, Claude Desktop, and many others. And this can all be done without having to write a specific integration to each client. So let's explore this further, because usually pretty diagrams are usually helpful for me, so hopefully they'll help you too. Okay, so we've talked about what MCP is. Let's talk a bit more about how it works. Many see MCP as one of the main protocols for the agentic ecosystem, and this is because of how easy it is to use one large language model to interact with an agent on a completely different framework and work seamlessly together. To explain this, I've created a diagram showing an AI-powered assistant that uses an LLM at its core, but extends its capabilities through the Model Context Protocol using multiple MCP servers. These MCP servers can communicate with tools and systems that are potentially built in completely different languages. So we're looking at our diagram. The scenario is this. A user sends a query, whether it's a request for order information, support conversations, or user information. The AI solution takes the user's questions and passes it to the LLM. But rather than relying on the model's internal knowledge, the LLM identifies specific information needs. These needs trigger calls to various MCP modules, each designed to handle a distinct domain or task. One MCP might fetch real-time order data, another might initiate the support conversations MCP to add some custom experience the user has already had to the context. A third could access a user profile information from a secure data store. Each of these MCPs return a structured response, and the orchestration layer baked into our AI solution then uses this context, sending it to the LLM with the original prompt to add more context. Now the LLMs have both the original user's prompt and live contextual information, allowing it to generate responses that feel smart, personal, and relevant. This dynamic back and forth between the LLMs and MCPs turns a user's query into a detailed, context-rich response. So far, most of the stuff I've talked about have been around retrieving data, and MCP servers do not specifically have to be for information retrieval. Your order information MCP could easily turn into a place order action, so a user's prompt could instigate an order being placed in your own system. This leads quite nicely into one of the features of MCP that I haven't talked about yet, and is probably one of the most important, and that is tool calling. MCP natively supports tool calling, meaning allows models to understand the full context of a task. For example, with our scenario, this model will be aware of the available tools that can be used to help answer the user's questions, which we have order information, support conversations, and user information. The input needed for these tools, for example, the order information MCP, might need an order number to retrieve the information. The MCP will provide an input schema to the LLM so that it understands the user needs to be asked for this information. Without us needing to implement additional logic, the LLM will then decide to ask the user a question of what is the order number, and then when the user fills in that order number, it will then proceed to call the MCP server with that input schema filled in. The output provided from the tools called will also be added to the context. So when that tool responds, that context will then also be added to the prompt, to the context. And all this information is delivered in a structured way for us through the model context protocol. Instead of hard coding how and when tools are called, the model dynamically decides which tool to use based on the context. So to conclude, I do think MCP is a big game changer. It lets us build smarter AI systems that understand the context and know when to use the right tools without all the messy wiring behind the scenes. It means we can build faster, integrate cleaner, and give our customers way more powerful, flexible solutions. At the end of the day, it's not just about building AI, it's about building AI that knows what it's doing, and bringing in extra concept from already existing systems is an absolute game changer in my experience. If you have software that you think you can benefit from adding AI to, or you want to make it available to your users through AI tools, then I strongly recommend using Model Context Protocol. At NewOrbit, we are working with our clients to do this today. If you'd like to know more about how you can do this too, please get in touch. We're always happy to help. I very much appreciate you watching this video to the very end, and catch you all later, and thank you for watching.